All right, in this last video in section 13.2, we're going to look at question number 7. Now this question deals with a function of 3 variables, okay, and it says that the temperature T measured in degrees Celsius at a point XYZ in a room is given by the function T of XYZ is the square root of 25 minus x squared minus y squared minus z squared. Okay, so a little bit of a different setup than question 6. Okay, this is now what we're looking at. So we have a location in space, right? This is some point in our room, and to measure the temperature of that location, well, we're just using our temperature function here, okay? So little example, so just to illustrate, say at the point, let's say 304, okay, the temperature at this location would just be T of 304. And if you plug 3 in for x, 0 for y, and 4 in for z, turns out you're just going to get a 0 underneath the square root. So here, in fact, we are going to be at a freezing temperature at this particular location. Okay? So again, we're now feeding the temperature function all 3 spatial coordinates, right? The location in the room to get our temperature. Okay, cool. So now what are we going to do? We're going to describe the isothermals of this function. And like what we saw in question 6, this is just a collection of points at a fixed temperature, right? Now here, since we're talking spatial stuff, we're going to ask, well, what are all the points in our room that are at a particular temperature? And if you give that some thought, right, that is, well, not going to be just a curve. It's in fact going to be an entire surface in 3-dimensional space. Okay, so here, let's go ahead now and start describing these level surfaces. So again, we'll call them the isothermals, right? Iso means same, so same temperature, surfaces at a constant temperature. And we can go ahead and do this in exactly the same way we do for functions of 2 variables. We're just going to set our temperature function equal to a constant, which in this problem would translate to the statement that the square root of 25 minus x squared minus y squared minus z squared is equal to c. Now I'm going to go ahead and rearrange this a little bit. I'm going to square both sides and move the x squared plus y squared plus z squared to one side. So I'm going to get x squared plus y squared plus z squared is equal to, and I had a square here, so I'm going to get a 25 minus c squared. Okay, and now, right, we can identify this as the equation of a sphere. So I'm going to rewrite the right-hand side. And so I can say x squared plus y squared plus z squared is the square root of 25 minus c squared quantity squared. Okay, so yeah, these are spheres centered at the origin with radius r is equal to the root of 25 minus c squared. Okay, nice. All right, so before we look at the graphs, I do want to make 2 comments here. So one comment is just going back to this statement right here, that the square root of blah, 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 blah is equal to c. Well, notice this is a positive square root. Okay, so that's saying no matter what I input for x, y, and z, this left-hand side can never come out to be negative. Okay, so we're really saying here that c has to be greater than or equal to 0 degrees. Okay, so that's just saying there are no temperatures in the room below freezing in this case. All right, the other thing I want to comment on is in relation to the expression for the radius, right? In order for this thing to be real valued, we're going to need 25 minus c squared to be greater than or equal to 0. Okay, now that's saying what? That's saying that C has got to be less than or equal to 5 degrees. Okay, I can ignore the negative root because of this condition here that C can't be negative. So here this is just saying, well, our maximum temperature could be as large as 5 degrees Celsius. Okay, cool. So now let's go ahead and look at the graphs of these various isothermals. Okay, so a couple things to highlight. Notice when C is 0, so in other words, when we're at freezing temperature, if I plug 0 in for C, I'm just going to get this square root of 25, which is just 5. So we're saying that this outermost sphere is a sphere of radius 5, and it consists of all points in our room, right, that are at a freezing temperature. And now as I increase C, right, from 0 all the way up to 5, right, what's happening to my radius? Well, this thing is going to get smaller as we increase C. So that's why we see for, say, C is 1 degree, 2 degree, 3 degrees, so on and so forth, right? We see the radius here decreasing. And in particular, right, when C is equal to 5 degrees, which we noted, right, that would be the maximum possible temperature. That's going to happen just right here at the origin, just at a single point, right? If I plug 5 in for C, I'm going to get 0 for the radius. So it's a sphere of radius 0, or equivalently, right, it's just a single point there. Okay, cool. So these then are our level surfaces, our isotherms. And then lastly, right, the question says, where in the room is the temperature the greatest, and what is the greatest temperature? Okay, so here we can see, well, the temperature here has a maximum of 5 degrees Celsius. So we can say the temperature is a max of 5 degrees Celsius, and this occurs just at the single point in our room, which is located at the origin. Okay, well, great. That's going to do it for this problem.